All right, let's dive into a classic coding interview question. This is one of those problems that can really separate the good developers from the great ones. We're going to find duplicate elements in an array, but there's a twist, a fun little constraint that forces you to think outside the box.
And listen, this isn't just some random brain teaser. Nope. This is a real question that has actually shown up in interviews for big tech companies like TCS and Infosys. Nailing this shows you can be creative and efficient, especially when you're given constraints. So, let's lay out the basic mission. It seems simple, right? You get an array, a list of numbers, and your job is to figure out which numbers show up more than once. Easy enough on the surface.
But here's the catch. This is what makes it a real puzzle. You are told you absolutely cannot use a hash map. Now, a hash map would normally be your go-to tool for counting things, right? But since that's off the table, we have to get clever and find a totally different way in. So where do we even begin without our trusty hash map? Well, our first move is surprisingly simple, but it is a complete game changer. We sort the array. That one single action is going to unlock the entire solution for us. And you can see the magic right here. Just look at the difference. Before sorting, our duplicates, the 2s and the 3s, are all scattered. But after we sort it, bam, all the identical elements are now sitting right next to each other. They're neighbors, and that is the pattern we're going to use. Now that the array is all neat and tidy, the logic is almost laughably easy. All we have to do is walk through the array, starting from the second number, and just ask a simple question. Hey, are you the same as the guy before you? If the answer is yes, congratulations, you've just found a duplicate. But hold on, we've hit a little snag. What happens if a number shows up, say, 3 times? In an array like this one, our simple loop would see the first 2 2s and say, hey, a duplicate. Then it would move to the next 2 and say, hey, another duplicate. We don't want to report the number 2 multiple times. We just need to know that 2 is a duplicate, period. So what we really need is a place to put our answers where it's impossible to add the same number more than once. We need a way to keep track of the duplicates we've already found. And for that job, we have the perfect tool, a set. You see, a set is a special kind of data structure with one golden rule. It only stores unique things. If you try to add an element that's already in there, it just ignores you. It's basically a bouncer for our list of duplicates, making sure no one gets in twice. So this makes our logic so much cleaner. Now, as we walk through our sorted array and find a matching pair, we don't just print it out. Instead, we just try to add it to our set. And the set does all the hard work for us, automatically making sure we only store each duplicate value one time. At the very end, whatever's in the set is our final answer. So let's put it all together. Here is our final polished algorithm in 5 clean steps. Step 1, sort the array. Step 2, make an empty set. Step 3, loop through the sorted array. Step 4, if an element matches the one before it, toss it in the set. And finally, step 5, return that set. It's elegant, efficient, and best of all, no hash map in sight.
And just like that, you've done it. You've taken what seems like a tricky problem with a tough constraint and turned it into a clear, smart, and efficient solution. This is exactly the kind of thinking that interviewers love to see.
But hey, before you go, here's a little something to chew on to really push your skills. Our solution used a set, which takes up a little extra memory or space. So how could you solve this same problem using no extra space at all? Could you do it just by manipulating the array itself? Now that's a fun puzzle to think about. Thanks for joining me.